But because the bridge to be lifted weighs an enormous 260 tons, it needs an additional add-on, the so-called Y-guying system. The rigging of the crane is now complete. In order for it to be adjusted to the correct height, it has to rest on these adjustable jack posts. The operators of the telescopic and lattice boom cranes now take up the strain as uniformly as possible.
Precise coordination between the crane operators is now crucial so that both lift in concert. If the weight isn't distributed evenly, the load may end up swinging.
And the transport modules could also get damaged if too much weight is focused in one place. And this needs to be closed as soon as possible so that the trains can run again. 2 days later, today, a temporary bridge is to be placed across the Buchenbach Valley. Prefabricated concrete elements that are attached to the old foundation with metal anchors serve as the beam seats. A steel girder is placed on top. The new bridge is due to be lowered down in 1 hour.
Everything must be absolutely perfect. We're working to almost millimeter precision, and the temporary bridge has a high intrinsic weight, roughly 90 tons. So everyone needs to know exactly what they're doing when the bridge is lifted in, and that's got to be planned in detail.
Meanwhile, the old bridge has been largely dismantled. The new one consists of 2 segments, one for each track. Their weight? 3 monster machines, one mission, installing railroad bridges.
Don't yell, I can't understand.
A crane is deployed to a wind farm by Jever, near the North Sea coast. The rotor hub of this wind turbine has to be replaced at a height of 97 meters. The gross weight of the 9-axle giant, 108 tons, 12 per axle. But because of its size, 22 meters long, 3 meters wide, and 4 meters high, it's only allowed to drive on the road between 10 p.m. and 6 a.m.
I'm now driving from Jever toward Flensburg, where a railroad bridge is to be installed with a second large crane.
After a nearly 2-hour tandem lift, the 2 cranes have successfully completed their mission.
We managed to get the bearings into the rebar, and the bridge is resting on the post points.
Heavy machinery or cranes are not permitted into the conservation area. A specially constructed plateau serves as the foundation for one of the most powerful cranes in Germany, the Liebherr LR 11000. The lattice boom crawler crane with a maximum lifting capacity of 1,000 tons is to lift the old bridge out and set it down here on the asphalt.
Was configured specifically for this deployment and satisfies all the safety criteria demanded for the job. This is the so-called ballast tray, and we'll stack it with 225 tons during the actual lift.
The complicated task of swapping an old, dilapidated railroad bridge for a 2-section temporary bridge has been successfully completed. A challenging lift for everyone involved.
When you always do wind turbines, you get into a certain routine as the procedure is always the same. The workflow for a project like this is completely different, and that makes it a whole new challenge for the crew.
But Thomas Klei and the other crane company workers can't put their feet up just yet. Tomorrow, they have to completely de-rig the crawler crane again. The tension in crane operator Thomas Klei gradually subsides. Prefabricated concrete elements that are attached to the old foundation with metal anchors serve as the beam seats. Everything's going according to plan.
It's turning easily now. Are you still lined up with your rail? Okay, by me. I was told that you over there need to adjust how far it is from the abutment.
Then the trains can run here once again. The bridge that the cranes will be installing is standing by at a rest stop.
It's taken around 4 weeks to weld, and we're now at the final stages.
The crew of a heavy haul company will now load it onto a modular transport trailer with 32 axles.
The problem is that the parking lot slopes down in one direction. But now the trailer is standing on an inclined parking lot, which means the distance to the bridge is greater on one side than the other. So we need to raise the left-hand side and add an extra wooden block so that we can then set the bridge down at an angle to the road level.
All that remains is to secure the load in place with the tensioning chains. Next morning, construction of the bridge's foundations begins. The workers attach it with lifting eyes.
Everything must be absolutely perfect. We're working to almost millimeter precision, and the temporary bridge has a high intrinsic weight, roughly 90 tons. So everyone needs to know exactly what they're doing when the bridge is lifted in, and that's got to be planned in detail.
The so-called trough bridge is 46 meters long, 8 meters wide, 3¼ meters high, and weighs 267 tons. A structural steelworks engineering company built the bridge in sections and then welded them together here. The telescopic crane still needs counterweights for the hoisting work. Just the base plate for the ballast, which the crane operator now lowers in place, weighs 11 tons. Then the ballast plates are installed. The smaller ones weigh 5 tons. The larger ones, 10 tons. To attach the blocks to the hook, the crew use a ballasting spike.
That's the spike that supports the ballast. It's inserted into the triangular hole and locked in place. My colleague inserts the spike and it goes all the way until it can't go any further. And now it's locked.
The Buchenbach Creek, a tributary of the Mur River by Affalterbach, northeast of Stuttgart. The valley has been designated a nature reserve, and this bridge is the only way to cross it. It's used by the suburban trains, for now. The fact is, the 26-meter, 100-year-old steel structure is showing signs of fatigue, and the bridge has had to be strengthened with additional metal struts several times already. DB Netz, a subsidiary of German Railways, is responsible for the upkeep of railroad bridges like this. Project manager Marco Henrichs summarizes the situation.
The authority responsible for bridges won't allow any further retrofitting, which means the bridge has to be demolished. And if the bridge isn't removed, the line could be closed.
Swapping the bridge out is a complex task. Heavy machinery or cranes are not permitted into the conservation area. As a result, the engineers intend to operate from a staging area located 60 meters from the creek. A specially constructed plateau serves as the foundation for one of the most powerful cranes in Germany, the Liebherr LR 11000.
With this crane, we can load up to 450 tons of ballast.
The main boom consists of several 18-meter-long sections that the riggers have to assemble today to create the 96-meter-long lattice boom. It takes 40 truckloads to get all the parts for the crawler crane to the job site, many of which are oversized heavy haulers that are rolling traffic obstructions.
The problem is trying not to hit anyone else.
A specially constructed plateau serves as the foundation for one of the most powerful cranes in Germany, the Liebherr LR 11000. But the crane is still missing its gigantic boom. It has to be 96 meters long for this project. The bridge lift is due to start in a few days' time. The project manager of the crane company is Marco Wilhelm.
This is our biggest crawler crane. It was configured specifically for this deployment and satisfies all the safety criteria demanded for the job. It's a special job for us too, not the typical work we do.
And this man will operate the behemoth. Thomas Klei has previously used the crane to erect wind turbines, but a bridge lift is something special for him too.
Everything is bigger and everything you lift is heavier. You have to rely on the crew, the radio signaler.
The mega crawler crane now swings the bridge across the nature reserve. The steel in the century-old bridge will later be melted down and recycled. A yawning 28-meter gap is left, where until now, the railroad bridge spanned the Buchenbach Valley. 2 days later, today, a temporary bridge is to be placed across the Buchenbach Valley.